Good morning, students. The next area is the different types of properties of colloid. Various properties exhibited by colloid. Colloid exhibit sedimentation property or settling property, colligative properties, etc. But here we mainly go through the major properties, 3 properties exhibited by colloids. That is, first one is mechanical property. Mechanical property, you know, due to the very small size of the colloidal particle, we cannot view or observe the colloidal particle with our naked eye. For that, we use ultra microscope in order to observe the movement of colloidal particle. When such colloid is viewed or observed through an ultra microscope, then it can be seen that the particles are in a zigzag motion. The colloidal particles are in zigzag or random motion. This property was first discovered by an American botanist called Robert Brown, and under the name the mechanical property exhibited by colloid is called Brownian motion. Brownian motion, because that such property was studied by Robert Brown by the motion of pollen grains in water. And the zigzag motion of colloidal particle is called Brownian motion. Once more, this colloidal particle is observed with the help of an ultra microscope. Then only we can watch the movement of colloidal particle. This zigzag motion, you know, suspended particle does not exhibit Brownian motion. You know what is the reason? Yes, because they have large size. Due to this large size, suspended particle does not exhibit this Brownian motion. And about the kinetic molecular theory of gases, you have studied various postulates of that kinetic molecular theory, and one of the postulates is that gas molecules are in a state of zigzag motion or random motion. During the motion, they collide with each other and also with the walls of the vessel or container. Therefore, this Brownian motion is a visible proof for the kinetic theory of gases. That is mechanical property. Mechanical property of colloid is called Brownian motion. And the next property of colloid is optical property. Second property of colloid is optical property. That is optics connected with the light. Here first I give a schematic representation of this. This represents the source of light. It is passed through a converging lens, convex lens, converging lens, so as to obtain a narrow beam. And this particle or rays are passed through a colloidal solution, and the solution is observed with the help of an ultra microscope the path of the light becomes illuminated. That illuminated path is called a Tyndall cone, C-O-N-E. And this optical property exhibited by colloid is called a Tyndall effect. Once more, when a powerful beam of light is allowed to pass through a colloidal solution and the colloidal solution is viewed with the help of an ultra microscope placed in a direction perpendicular to the propagation of light, then the path of the light becomes illuminated. Path of the light becomes illuminated, and that illuminated path is called a Tyndall cone. Tyndall cone. When a torch beam or torchlight is passed in darkness during night, a torch beam is passed in dark area, you can see that particular beam, torch beam, is illuminated, and in that you can see that the dust particles are there. And also in theater also, from the projector to the screen, when all the lights are switched off, then it can be seen that in the dark area only the light from the projector is illuminated. That illuminated area is called a Tyndall cone. And this optical property is known as Tyndall effect, and the Tyndall effect is due to scattering of light. It is due to scattering of light by colloidal particle. Scattering of light by colloidal particle. Here, due to very small size, true solution particle does not exhibit this Tyndall effect. Clear? That is, once more, when a powerful beam of light is allowed to pass through a colloidal solution, and this colloidal solution is observed with the help of an ultra microscope, the path of the light becomes illuminated. That illuminated path is called a Tyndall cone. And the optical property shown by colloid is called a Tyndall effect, and the Tyndall effect is due to the scattering of light by colloidal particle. That is the second property under this optical property. First one is mechanical property, or mechanical properties shown by colloids are called Brownian motion. Optical property is called Tyndall effect. And the third one is electrical property. Before explaining this electrical property, here just listen. Colloid are either positively charged or negatively charged. The charge of colloid is either positive or negative. Metal hydroxide, hemoglobin, etc. carries positive charge, while metal sulfide, rubber latex, etc. carries negative charge. Then a question or a doubt usually arises. What are the different way by which this colloidal particle acquire charge? Or what are the different methods by which colloidal particle acquire charge? They gain charge mainly by this following process. First one is the frictional electrification. Frictional electrification caused by the mutual rubbing of dispersed phase and dispersion medium. Frictional electrification arises due to the mutual rubbing of dispersed phase and dispersion medium. Second method is the preferential adsorption of ions from solution. If a particular colloid mainly adsorbs positive ions, the charge becomes positive. At the same time, if they adsorb negative ions, charge of the colloid becomes negative. That is called a preferential adsorption of ions from solution. Third is electron capture from air. Electron capture from air or during Brodick's arc method. Metals are electropositive in nature. When they vaporizes, they lose electrons, or electron capture from air. By capturing that electron, they get negative charge. And fourth one, we have already studied, during the formation of this micellus, the anionic particle get aggregate, or if positively charged particle aggregate, in certain case they get positive charge, or formation of micellus. Formation of micellus. There is frictional electrification caused by the mutual rubbing of dispersed phase and dispersion medium. Preferential adsorption of ions from solution. Electron capture from air, and formation of micellus or micellus formation. During this process, this colloidal particle gain charge. They are either positive or negative charge. These are the different way by which colloidal particle acquire charge. They are either positive or negative. Till then we didn't mention what is the name of the electrical property. I will tell that name after some time. That is, these are the different way by which colloidal particle acquire charge. They are either positive or negative. When this colloidal solution is subjected to an electric field, or when an electric field is applied to colloidal solution, colloidal particle migrate just like electrolysis. Colloidal particle migrate towards electrodes of opposite charge. That is, colloids are either positive or negative charge. And when an electric field is applied, depending upon the charge on the colloidal particle, they move towards electrodes of opposite charge. That migration or movement of colloidal particle under the influence of an electric field is called electrophoresis. It is called electrophoresis. And in that, there is electrical properties of colloid is called electrophoresis. And in that, if the colloidal particle migrate towards anode, it is called anaphoresis. it is called anaphoresis, and if they migrate towards cathode, it is called cataphoresis. It is called cataphoresis. If it undergo anaphoresis, migrate towards anode, charge of the colloidal particle is negative, and if it migrate towards cathode, charge on the colloidal particle is positive. And anaphoresis and cataphoresis. And in order to understand this concept, you just note this pictorial representation. The first diagram before electrophoresis. This is before electrophoresis, before completing the circuit. This is after electrophoresis. Got the difference between these two? Before electrophoresis, colloidal solutions are almost uniformly distributed in the U-tube. After electrophoresis, what happened? All these colloidal particles are migrate towards cathode. Isn't it? Therefore, it is cataphoresis. And also, the charge on the colloidal particle is positive. Colloidal particle migrate towards electrodes of opposite charge. That migration is called electrophoresis. Typically, here it is called cataphoresis. Clear? Generally called migration called electrophoresis, and depending upon the electrode, that electrophoresis is modified as anaphoresis or cataphoresis. And the colloidal particle attract the counter ion. Colloidal particle attract the counter ion from solution. Counter ion means if colloidal particle is positively charged, counter ion negative charge, and vice versa. But that differs in their magnitude. Suppose colloidal particle carries positive charge, they attract the counter ion from the solution. That is, definitely there will be some potential difference. Positive and negative charge are not identical. That is why they differ in their magnitude. Colloidal particle attract the counter ion from the solution and forms an electrical double layer on the surface. That electrical double layer is called Helmholtz double layer. Helmholtz double layer. Normally, the charge on the colloidal particle is called a fixed layer, while the other is called a diffused layer or mobile layer. That is, the double layer is split into fixed and a diffused layer, and this electrical double layer is totally called a Helmholtz electrical double layer or Helmholtz double layer. Normally, a potential difference arises between this double layer. This potential difference is called theta potential. The potential difference between this double layer is called theta potential or electrokinetic potential. Zeta potential or electrokinetic potential. I explain this one more. Colloids are either positive or negative charge. They attract the counter ion from solution and forms an electrical double layer. As a result, a electrical double layer that consists of fixed layer and a diffused layer. That electrical double layer is called Helmholtz double layer. Normally, since the magnitude of both this fixed and diffuse layer are different, a potential difference arises at the surface. That potential difference is called zeta potential or electrokinetic potential. And the major properties shown by colloids, what is mechanical property called Brownian motion, optical property, Tyndall effect, and electrical property electrophoresis. That electrophoresis means the migration of colloidal particle under the influence of an electric field is called electrophoresis, and the colloidal particle migrate either towards cathode or anode. They are called anaphoresis or cataphoresis. And in higher level competitive exam, one more point, that is at a particular pH, this colloidal particle will not migrate towards any of that electrode. That particular pH is called isoelectric point. Isoelectric point. And colloidal particle attract counter ion from the solution and forms an electrical double layer. That electrical double layer is called Helmholtz double layer, and the potential difference between that double layer is called electrokinetic potential or zeta potential. And next is about coagulation. Coagulation. Coagulation means it is the process of precipitation of colloid. Process of precipitation of colloid is called coagulation. You know, in the case of blood, we call it clotting of blood. Blood is a colloidal system. Generally, it is called coagulation, precipitation. Beginning of coagulation is called flocculation. Beginning of coagulation is called flocculation. Coagulation can be brought about by mixing oppositely charged colloid. Mixing oppositely charged colloid, or by adding excess of electrolytes, or by adding excess of electrolyte. You know, cloud is a colloidal system, belongs to liquid aerosol, means water droplets dispersed in air. That heterogeneous system is called a cloud. When this electrically charged sand particle, silicon dioxide particle, is spread over cloud with the help of an helicopter, there you can see that the charge get neutralized, colloid destabilize, water droplets aggregate to form rain. This is the principle of artificial rain. Artificial rain. And second is coagulation can be brought about by adding excess of electrolyte. Excess of electrolyte means from a wound, suppose bleeding takes place, when a piece of ferric chloride is kept at the mouth of wound. Ferric chloride is an electrolyte. Blood undergo coagulation or clotting of blood takes place. that is indicated by the second factor, that is by adding excess of electrolyte. In both cases, coagulation can be carried out. Beginning of coagulation is called a flocculation. And here is an important rule that is called a Hardy-Schulz rule. Hardy-Schulz rule. Hardy-Schulz rule states that greater the valency of flocculating or coagulating ion, greater the valency of coagulating ion, greater is its coagulating power. That is, depending upon the valency of coagulating ion, coagulating power also increases. Clear? Valency, as the valency of the coagulating or flocculating ion increases, coagulating power also increases. And we can explain separately by taking anions and cations. Thus, the coagulating power of cation to coagulate negatively charged salt. To coagulate negatively charged salt increases in the order Na plus Ba2 plus Al3 plus etc. Means as the valency of the flocculating ion increases, their coagulating power also increases. Okay. Similarly, the coagulating power of anion to coagulate positively charged salt increases in the order Cl minus, SO4 2 minus, PO4 3 minus, etc. That is, greater the valency, greater is its coagulating power. The coagulating power increases with the valency, that is Hardy-Schulz rule. Simply, greater the valency, greater is its coagulating power, or the coagulating power increases with the valency. And by this question, you really understand this concept, that is BaCl2 is better than AlCl3 to coagulate As2S3 salt. BaCl2 is better than AlCl3 to coagulate As2S3 salt, arsenic sulfide salt. What is your opinion? What is your opinion regarding that? You know, As2S3 metal sulfide, they carries negative charge. In order to coagulate a negatively charged salt, we depends the valency of cation. Here, two cation, that is barium chloride provides Ba2 plus, aluminum chloride provides Al3 plus. According to Hardy-Schulz rule, greater the valency of coagulating ion, greater is its coagulating power. Therefore, Al3 plus is better than BaCl2 to coagulate As2S3 salt. The given statement is wrong. we have to modify that AlCl3 is better than BaCl2 to coagulate As2S3 salt. In question paper, BaCl2 is better than AlCl3 to coagulate As2S3 salt. Do you agree with that statement or give justification? That is, we oppose that statement because this is the explanation. BaCl2 provides Ba2 plus ions, AlCl3 provides Al3 plus ion. According to Hardy-Schurz rule, greater the valency, greater this is coagulating power. There is another term, that is flocculation value. Flocculation value. It is the minimum number of millimole, not in mole, millimole of the electrolytes, minimum number of millimole of the electrolyte added per liter of solution, added per liter of colloidal solution to bring complete coagulation. That is called a flocculation value. Okay. And about this properties, that is three properties, namely mechanical property Brownian motion, optical property Tyndall effect, electrical property electrophoresis, and about a Helmholtz double layer zeta potential, then coagulation, how this coagulation can be carried out. It can be carried out by two ways. One is direct mixing of oppositely charged colloid or by adding excess of electrolyte. I already cite example for each one. And about this coagulation, there is an important rule that is called the Hardy-Schurz rule, which states that greater the valency, greater is coagulating power, or coagulating power increases with increase in valency. And then flocculation value, that Hardy-Schurz rule you can easily understand by this question alone. That's enough, more than enough. That is, here three concepts are, one is charge on the cation, charge on the negative charged colloid because it is a metal sulfide. Already we mentioned that metal sulfide carries negative charge, and Hardy-Schurz rule. That is the most important one. Greater the valency, greater is its coagulating power. And in this lesson, the remaining thing is about the protective colloid and emulsion. Two types of emulsion. I already given two examples such as milk and cod liver oil. After that, what are the major application of colloid? What are the important applications of colloid? All these things we can discuss in the coming class. Okay, I think it is very simple lesson. You can just answer the types of question and you just go through the previous board exam questions. Okay, thank you all, and the remaining we will discuss in the next class. Okay, bye.